As promised, descriptive statistics, last video about measures of central tendency and the appropriate use of the measures, levels of measurement to determine when, where, and how to use the different measures to characterize central tendency. An intimately related concept is the dispersion. So central tendency is sort of an ordinary value on a variable, and beyond that, once we've settled on which one we want to use to describe an ordinary value, we want to then say something about the dispersion of the observations on the variable around that central tendency, around that ordinary value. And I want to talk about three different ways to talk about dispersion. Really, this first one is not dispersion so much as it is the sort of the last resort when we're dealing with nominal level data. We don't want to say anything about dispersion of observations around a central tendency when the variable is measured at the nominal level. Multi-categories, and the categories themselves have qualitative meaning, recall, and they have no quantitative meaning. We do, however, want to describe the range of every nominal and every ordinal, actually everything. Ratio also. When you're describing a variable's dispersion, you really ought to start with what can happen, and that's what the range means. The range is the highest value that the variable can take, and also the lowest, so and what's in between. Lowest to highest, so we're going to go to our nominal level variable. The way you do this descriptively, remember now that number one on OS, the operating system, number one is OS X, number two is Windows, and number three is Unix. What I just said is the description of the range. I have a variable numbered 1 to 3 where 1 is the Mac OS, 2 is the Windows OS, and 3 is Unix. That description is really all you can do with a nominal level multi-category measure. Speak and describe from lowest to highest. If you have a scale of partisanship that runs from 1, where 1 is strong Democrat, to 7, where 7 is strong Republican, then you need to say that as well. That's a description of the variable's range. It's also critical to distinguish sometimes between a theoretical range and an observed range, whether it be a nominal or an ordinal or a nominal, ordinal, or ratio interval, doesn't matter. Your variable could have an observed range that's very different, truncated maybe, but very different than its theoretical range. In theory, test scores here range from 0 to 100. Someone hypothetically scored 100 on the test. No one scored 0. The lowest score on the test was by Jack, poor fellow. Jack made a 41. The theoretical range of the variable is 0 to 100. The observed range is 41 to 100. That could come into play if you have even a nominal level measure like religion, and one of the categories is Islamic, and no one in your observed sample identifies themselves as Islamic. That's an example too where the observed and the theoretical range could be different. These are important things to discuss when you're describing data, describing actual observations on a variable. These two things are really about dispersion. And dispersion is really about distances from actual observations on the variable from a measure of central tendency. And these things are really come into play with ordinal, and these two come into play with ordinal and with interval and ratio level measures. And they're different depending upon the nature. You sort of go a different way descriptively depending upon the nature of the distribution of the variables. Last time I illustrated a quirk, a distributional quirk, by introducing a 50-year-old into a class of students, 9 of the 10 are between 18 and 21. You have a non-traditional student who's my age, 50 years old, and this blows up the mean as a way to describe. Here's X bar. Don't know if you can read this. I mentioned last time the mean on age is 22.4. No one in the class, only the one person, only the 50-year-old in the class is over 22.4. So it's a really bad description of central tendency for these data. This is 10 data points and a nice little illustrative example. I actually want you to work these statistics on these data when and where appropriate. We'll do that in class. 10 data points, you never really work with data. I describe 10 data points. I described the class as a small data class as opposed to big data class. Not this small. We don't really work unless just sort of theoretically with 10 data points very often in social science. We work with a lot more. So let's say we had 1,000 data points, and then sort of on the y-axis on these three distributions, we'd be talking about the number of times we observed the value. This is really smooth because we got a lot of data points. And here would be the score on the x variable. So if this were age, now I'm probably not dealing with 17 to 21 year olds, but 18 to 21 year olds. Let's say 18 to 75, and thousands of observations. Obviously, observations are gathering up here, they're gathering up here, and they're gathering up here at the peak. So these curves are sort of describing the number of observations that are beneath that are beneath them, and they take different shapes. These curves are also different in terms of what's called the skewness, S-K-E-W-N-E-S-S, skewness, and you find this in the materials that I assigned. So to give it a description here, here's a distribution with no skew. It is also, this little squiggly means is distributed, and capital letter N is used to describe shorthand the normal curve. This is a bell curve. It's a normal distribution. It is symmetric. It's wonderful. And whenever you have this, you're going to want for a measure of dispersion the variance and the standard deviation, and you're going to want for a measure of central tendency the mean, the arithmetic mean. It's when you don't have the other one, sometimes ubiquitous normal curve for your data, that you would turn and look at alternatives to describe. We've already seen the central tendency. Central tendency here is best described by the median, which is 19.5. Much better description of the ordinary value on this variable than the alternative 22.4 from the mean. And when you're using the mean, you use the standard deviation and the variance. Question relative to dispersion: what do you use as a measure of dispersion when you would use as a measure of central tendency the median? Those things come into play in these two circumstances. I find that students get these confused very easily on a quiz or a test. Tend to know what they're talking about and yet flip them. I'm not sure why. So I want to get this down carefully. The positive skew, just look for the long tail on the right. And for negative skew, look for the long tail on the left. Both of these circumstances are circumstances where outliers here on this side, outliers here on this side, are going to make the mean a risky proposition as a character to characterize the ordinary values on the variable. And so you're going to want to turn instead to the median. And when you turn to the median, there's a much more natural description, really, of dispersion, known as the average deviation. What we're doing here, in case you can't see it, is the summation sign. This is x sub I, an observation on the variable. I'm taking out the median and sort of subtracting the median from every observation on the variable and then dividing by the total. So again, dividing by the total after we've taken the absolute value. If you didn't take the absolute value and you sum these things up, then you'd find 0. So you're getting rid of the negatives and finding dispersion. And what the average deviation tells you is how far on average in Euclidean distance, how far on average are the observations from their median. It's a very natural descriptive tool, and we look over here to the age variable, and we had noted that 22.4 was bad, the mean, as a description of central tendency, that 19.4 was better. When we look at the average deviation versus the standard deviation given by this formula, the standard deviation is 9.77. So does that describe how these things are typically dispersed around a central tendency? Not very well. All but one of these is just the greatest distance between points is from 18 to 21. That's the greatest difference, let alone the average distance. Now the average deviation is affected by the presence of this big number by age 50, but not nearly so much so. The average deviation, and I actually did that, not by hand, but just looking at it. So someone should check that the average deviation is 4. I think it is. It looks like that the sum there is going to be 40. Divided by 10. So much better. Much better. And these are this is a circumstance where there is a positive skew. I'm outlining out here the person who is 50. And it could happen in the other direction. And the reason it has such a profound effect on measures of dispersion, skewness, is because of what's going on in this formula. This is lowercase letter s, subscript x. And here we're putting under the square root because it's the standard deviation. The variance is this formula without the square root sign. So the standard deviation is the square root of the variance. Again, we're summing across observations with the central tendency measure subtracted out. This time it's the mean, and we're squaring it. And here we use the absolute value to get rid of the negatives. Here we're using the square, dividing through by n minus 1 instead of n, and the rationale for that we'll talk about under inferential statistics. For right now, don't worry about it. The n minus 1 thing. Boy, when you square something big, you make it really big. And it's that process, the process of squaring things, that so throws off the variance and the standard deviation as measures of dispersion. What's going on here is just squaring this for the purpose of getting rid, descriptively, for the purpose of getting rid of the negatives, taking the square root, hopefully to situate the measure back down into one that would make sense on the scale where the variable is measured. And yet you can see when there's an outlier or alternatively a skew in the distribution, you get a different answer. Over here you can see a much more well-behaved, where I have no skew. It's a much more well-behaved ratio level measure. The grades, average, the mean is 77.5. This is versus 77 for the median, so they're very close. 17.68 on the standard deviation and 13.7 on the average deviation. The differences there would go away if we had a lot more data. The main difference there is between those two. The average deviation and the standard deviation is being driven almost entirely by subtracting 1 from n. These are really identical qualitatively discussions about the dispersion on the variables for the variable test, and of course we get something wildly different on the variable age. So these two things are for ordinal data, they're for interval data, they're for ratio data, and you would choose one strategy over the other depending upon whether you chose the median or the mean as the measure of central tendency. All of your variables that you discuss ought to spell out to the reader the range, both in theory and the observed range. So, that's it. That is the talk on measures of dispersion. These two things, measures of dispersion and measures of central tendency, are statistically very, intimately related. I'm going to make another video that's a more advanced presentation. It's actually a very new presentation. I found it online this summer. And why would you want to watch the next video? Or who should? You should watch the next video if you're really getting this, really getting this, and you want to get it at a level deeper, and you have some preparation or background in math. And I assigned the web-based as an option. The web-based source of the talk that I'm about to give is very brief. And if you look at that source and you see something there that interests you, that might make you want to dig a little bit deeper into here, and you have the background to follow along, then you should watch the video. Nothing on the second video will be tested, even quizzed. I may talk about it in class a little bit, but probably not very much. These two things, though, everything on the first two videos, measures of central tendency, when and where and how to use them, measures of dispersion that come as complements sometimes, when and where to use them. These are all testable things. So try these out for yourself, the formula and the data. And that's the end of this one.